Alrighty, this is video notes for section 9.7, factoring using special products. So thinking back to what we did in 9.3 when we were multiplying using special products, if we had a plus b in parentheses squared, we knew that our final product had to be in the form a squared plus 2ab plus b squared, where a squared is the first term squared, 2ab is 2 times the first term times the second term, and b squared is the last term squared. If we had polynomials in the form a minus b squared, our product had to be in the form a squared, or the first term squared, minus 2ab plus b squared. And if we had polynomials in the form a plus b times a minus b, our product, when we multiply, would have to be in the form a squared minus b squared, or the first term in each one squared minus the second term in each one squared. So we use these rules in order to quickly find the product of two polynomials. So here when we're factoring, we can also use these rules to work backwards to quickly find the factors of a polynomial. So if we have a polynomial over here in one of these three forms, we can work backwards to quickly find its factors using our rule. So looking at number 1, it asks us to factor the polynomial a squared minus 49. We can rewrite a squared minus 49 as a squared minus 7 squared. So this looks very similar to our rule that has a squared minus b squared as a final product. And we know that a squared minus b squared is equal to, if we work backwards using our rule, it's equal to the factors a plus b times a minus b. So we need to find our values for a and b. A is simply equal to a here, and b is equal to 7. So when we plug those in, we will get a plus 7 times a minus 7. So we're just using the rule to quickly see how we can find the two factors. Again, in number 2, we have x squared minus y squared. Again, this is in the form of a squared minus b squared, where a is equal to x and b is equal to y. We know in order to get a squared minus b squared, we must have the factors a plus b times a minus b. So we can plug in our values for a and b, and we get x plus y times x minus y. Could we factor the polynomial out like normal, like we've been doing? Yes. Using this rule is just a way to do it quickly. If you see the pattern, great. If not, you can still factor it. Number 3. We have x squared plus 12x plus 36. We can rewrite this as x squared is just going to be x squared. Our last term, 36, is the same thing as 6 squared. So our middle term, we want to get using that 6 and that x, is the same as x times 6 times 2 will give us 12x. So we can see this is in the form of a squared plus 2ab plus b squared, where our a is equal to x and our b is equal to 6. And using our rule, we can look back. In order to get a squared plus 2ab plus b squared, we have to use our first rule that tells us the factors must be a plus b squared. So we can plug in our values for a and b and get x plus 6 squared. And this is the same thing as writing x plus 6 times x plus 6. Remember, when something's squared, it's the same as multiplying it by itself. So either of these would be a correct answer for the factors. Alright, last one, number 4. We have y squared minus 6y plus 9. We can rewrite this as y squared as our first term. Our last term, 9, we can write as 3 squared. So that middle term, we have 3 and y, our y times 3, times minus 2 will give us minus 6. We have minus 2, y times 3. So, we look and see this is really similar to a squared minus 2 times a times b plus b squared. And our rule tells us that the factors then must be in the form a minus b squared. Here, our a is equal to y and our b is equal to 3. So we plug these in to our formula, our rule, and we know that the product must be y, or the factors must be y minus 3 squared, which again is the same thing as y minus 3 times y minus 3. You can write your answer either way as factors. So go ahead and try the checkpoint using these special product rules to find the factors.